Okay, let me first do a quick comparison with what we have in the earlier parts of probability first. So far, when we calculate probabilities and you have a variable, we always write a certain number on the right-hand side. For example, you may have px equals to 5, you may have like px equals to 3, and so on. Where the probabilities that we are currently calculating for are always singular points. You want to find the probability when x takes on a certain number like 5, 6, 7, and so on. Whenever it's this kind of singular points, we say that your variable is discrete. The meaning of discrete is it's just one by one value, singular values. So for today, the first difference for our variable is that you're going to see this word called continuous. So it's no longer a singular point. When we say that it's continuous, means you're going to look at a range of values. We're going to get a range of numbers that could appear for your x variable. And we want to see the notations first before we discuss what the properties are. So let's say my variable is called x. And if we say that x follows a normal distribution, let's learn this notation first. The tilde that you see there reads as the word follows. N is your normal. So my distribution or my x is a normal distribution. What are the two values on the right-hand side? It will always come in this particular order. It will be mu first, then sigma squared. So what is mu? Mu refers to this thing called Ex. Let me write down how we should interpret this. Ex is read off as the expectation or the expected value of your x. So expectation is given by mu. Another phrase for the same thing is, this is also called the average or the mean of the variable x. So first value that appears after the n is the average. Second value that appears is this thing called VAR, which is your variance. So variance of x is given by sigma square. That is the usual notation for variance, but you also want to know what is sigma. So without the square, what does it mean? That is called standard deviation. Standard deviation symbol or notation is given by sigma this way. Okay, so I haven't told you what they mean yet, except that you should know the order. The two numbers must be written as mu and then sigma squared. So to understand what is this, we have to go through a few properties below. Let's start with this curve here, where you're going to see that this horizontal axis is given by x. The mean that we see is the middle of the graph. And your graph is symmetrical about the middle. You can think of this like a bell curve, where the middle is the highest. There is no y-axis, but we have to introduce just for this example. Usually we won't draw it in. Help me construct that y-axis, and what the y-axis represents is a probability density. I've explained what this means, but this is not the usual probability. It's a little bit different. Now, the higher you are, the greater the chance of that x value occurring. But to get that chance, we are going to look at something called area. Area under a particular region will represent the probability of your event. So for example, if I want to find the probability to be between A and B, if I want that to happen, we will mark out on the diagram where your A's and B's are. Suppose A and B's are here. Then we are trying to get this particular area that is in between them. This area between your A and B will give you a probability. Area is probability for this chapter. If we get the concept first, later I will show you how we do the calculations. So the concept of areas is going to be your probability for certain events. And because of area, now let's say I want to find a singular point. What is the area under 1 point? Area for 1 point will be nothing. And this is regardless of what is your A value. Every time you have a single point, the area should be thought of as there's no area. It's going to be 0 always. Therefore, for this kind of variables, when we want probability between A to B, both not inclusive, what is going to happen is even if I put inclusive at A, let's say I have an equal sign there, it doesn't affect the probability. It will stay the same. Just for today, the normal distribution variable has this property. And just for illustration purposes, even towards the right, when I compare with B, it's the same. If I put an equal sign at B, it doesn't affect the problem. So we compare with the previous week's distribution of variable. So today we have normal variable. A normal variable, let's write down this again. If I want probability less than 5, it is going to be exactly equals to the probability of lesser than equals to 5. The equal sign doesn't matter. It won't affect. You maintain the same number 5 on both sides. But last 2 weeks, we have this thing called a binomial distribution. Can I just write down the values first? Binomial distribution always takes whole numbers or integers like 0, 1, 2, and so on. These are the possible values for binomial. It's always whole numbers. It's not a range like there can be in between. It's always discrete whole numbers. So the main difference is when we have a binomial, what happens when you want x lesser than 5? Lesser than 5 will then be just from 0 to 4. We end at 4, not inclusive of 5. So the conversion looks a little bit different. For this situation, you should have less than or equals to 4. So the number will drop by 1 if you want to convert and have an equal sign. Okay, you need to be careful. It's different for a normal distribution. Okay, more properties. Total area under the curve must be 1 because total area refers to your total probability. Probability is always from 0 to 1, maximum of 1. So total area under the curve should be 1. You always get a symmetrical curve about the middle, and it will approach x-axis on the extreme ends on left and right infinity. This can be thought of as x-axis is an asymptote. You will get closer and closer to it at the ends. Okay, so to help you understand further on the curve, can we draw and compare the following? On the left figure, I would like to draw in 2 curves that has got the same mean but a different variance. We haven't seen where is this variance placed on the diagram. So let's use this to understand a bit more. Help me construct in the horizontal axis. Okay, like I said, for normal distribution curves, we are not going to draw in the y-axis. Where just draw in like what you have above for the diagram. A normal distribution curve, just a random one, where the middle value marked out as mu. Mu is always the center of your curve. If I would like to have a second graph that has got the same mu but different sigma, okay, let me draw in first, then I explain more to you. It will be flatter at the end, but in the middle it will be higher. at the same middle position with the same mu. Should look like that. This is a different curve where let's call this as x2. My black curve is x1. When you draw the x2, if it's higher in the middle, it must be flatter at the ends. The total probability must stay as 1. Total area must be 1 for both x1 and x2. Therefore, if it's higher in the middle, it must be flatter at the end. The total area is preserved as 1. So I know that they have different variance because the shape is different. But whose variance is larger or smaller? How do we compare? I write in the answer first, then I explain more. The variance of x2 is actually smaller than the variance of x1. How should we think about or visualize this? What is variance? So for your x2 curve, because it is higher in the middle, we should think about it as for your x2 curve, your values are more, okay, we can think of this word called concentrated at mu. Most of your area is contained in the middle because you have got a higher peak. Most of them are inside the center. If your values are concentrated in the middle, what this will also mean is that your spread is smaller. Spread refers to how spread out your x values are. Are your x values in the middle or are they at the ends? Because it's concentrated in the middle means they are not spread out. If it's not spread out, means that the spread is small. And spread is linked to the word variance. The concept of variance is how spread out your values are. If they are all in the middle, means the variance is smaller. And so we have this conclusion that variance x2 is smaller than variance x1. So in short, you can think of it as the higher your peak, the smaller the variance, because you have your values all in the middle. So you should think of sigma or variance as it will give you a different shape. Mu just means where's the center, but sigma actually represents how your shape is like. Is it flatter at the ends or what properties? The other one on the right, let's draw in. I want same sigma, but with a different mu. Same sigma will then mean that the shape is exactly the same. You have got the same shape, but different mu refers to the graph looks like it is translated, a moving one of the graphs. Okay, so let's draw in together. In my first graph, we just draw a random curve first, where this is at mu1. Let's call this as x1 curve. If I want the same shape but translated, maybe we just draw slightly towards the right. But I want the same shape, where this is mu2, this is x2. We should construct the same curve, just that it looks like it's a translation or a shifting towards the right.